Hello and welcome to our 12th video. My name is At-Tayyib Abu Yaman. This video will be about integration of sine x cosine x. The reason we chose sine x cosine x is that when we use integration by substitution and substituted for sine x, we got a different result than when we substituted for cosine x. And to demonstrate that, first we will go ahead and use the substitution for sine x and also get the results for substitution for cosine x to show that we get different results for both cases. But we will also prove that though the results of integration of the same function are different, yet both of them are correct. And we reach the conclusion that both of them are correct by undoing the integration, which is the reverse of the fundamental theorem of calculus. So we will do differentiation of the integration. And if we ended up with the original function that we integrated, then we succeeded in proving that the integration of the same function led to two different values, yet the two different values are correct. So let's get going. And the first thing is we'll just put integration of sine x cosine x dx. And then we will let u equal to sine x. We'll start with substituting sine x. So if u is equal to sine x, we do the derivative of both sides. So derivative of u is just du. Derivative of sine x is cosine x dx. Now we can solve for dx. So dx will be equal to du divided by cosine x. If we solve for dx, we'll get du over cosine x. Now we can substitute for sine x u and for dx du over cosine x. So integration of, instead of sine x u, cosine x remain the same. Instead of dx, we put du over cosine x. We can observe here that we have cosine x on both the numerator and denominator. We can cancel them. And our integration will be just integration of u du. And that will give us u squared over 2 plus constant as the integral. But then we will go back and replace u by its equivalent, which is sine x. That will give us sine squared x over 2 plus constant. So we will call this one equation number 1. Now we will go ahead and do the integration, but in this time we will use substitution for the cosine instead of the sine. So let u equal to cosine x. If we do the derivative of both sides, then du will be equal to negative sine x dx. And if we solve for dx, we will find out that dx will be equal to du over negative sine x. Now that we have the value for cosine x, which is u, and the value for dx, which is du over negative sine x, we will go to the original function and replace, instead of cosine x, replace it by u, and instead of dx, we replace it by du over negative sine x. And that is this. So if you compare these two, you can see that we replaced cosine x by u, we left sine x same, and we replaced dx by its equivalent, which is du over negative sine x. Now we know that we have sine x in the numerator and denominator, so we're going to get rid of them, and we'll end up having a function that's easy to integrate, which is negative integral of u du, which will be equal to negative of u squared divided by 2 plus constant. If we replace u by its original value, which is cosine x, then we will have the result negative cosine square x over 2 plus constant. This is our equation number 2. If we compare equation number 1 and number 2, they're not the same. Yet we will prove that both of them are correct. So the same function, its integration will lead to two different results. But the two different results are correct. we're going to go ahead and, like we said, we reverse the fundamental theorem of calculus, and we will do differentiation of integration. Now these are the results of the integration. We're going to go ahead and do the differentiation of this and the differentiation of this. And if the differentiation resulted in the function sine x cosine x, then we succeeded in our task. So let's go ahead and start. First, we will take the result when we used the substitution for the sine. So we derivative of the result by will lead us to 2 times sine x cosine x over 2. And we know that the 2 appears in the numerator and denominator. We can cancel them, and the end result, we're getting the original function that we integrated. This is for the first case where the substitution is for the sine. Let's take a look at the case for the substitution of the cosine. So the derivative of the result, which is minus cosine square x divided by 2, derivative will be equal to 2 cosine x sine x over 2. You can see that the negative sign disappeared because the derivative of cosine is negative sine. So negative was negative, now we have positive. We can go ahead and just go ahead and cancel the 2 because it appears in the numerator and denominator. And the end result is the same. So the end result is that we were back to the same function. Both the integration of the same function led into 2 different integrals, but these 2 different integrals, when we differentiated each of them, we went back to the same function. So both answers are correct. To summarize, what we did is, first of all, we started with integration of the function sine x cosine x, and then we used substitution, one time for u, one time u equal to sine x, the other second time u equal to cosine x. The result of substitution of u equal to sine x is sine square x over 2 plus c. The result for using u equal to cosine x is negative cosine square x over 2 plus c. Now if we did the derivative of the first result, which is sine square x over 2 plus c, we can see that the derivative will give us the original function, and the same thing applies to the other side. The result of the other side is negative cosine square x over 2 plus c, or a constant. If we did the derivative of this, we will also get the same. So the end result will be the same regardless of which path we take. So this is one of the importance of the fundamental theorem of calculus. And this looks like it's a little bit confusing that the same function will give us 2 different results, but the fundamental theorem of calculus came to the rescue. Thank you for watching this video, and you have a great day.